Hey, Math 31, I had a question coming out of section 9.1, number 37, and here we were asked, hey, here's a sequence, right? Can we write a recursive formula for that? Let me write recursive formula. And when you hear recursive formula, you have to define a sub 1 to be something, like some number, and then a sub n has to be some relationship with an n minus 1 in it, right? So again, current term has to be defined in terms of a previous term. And I put an addition sign there, but keep in mind it could be addition, multiplication, division, any of those operations. So let's go look at our sequence and see if we can spot a pattern. So if I look at these sequences, the first thing I try and do is see if there was a common difference or a common ratio. And what I mean by that, if I look from 35 to 38, I can notice that I added 3, and then I actually start to see the pattern. Right? I just keep adding 3, which is great. So getting to from term to term, I see that there's this common difference between them. All right, and when you hear me talk about ratio or R, I refer to this as if there was a common ratio, meaning multiplication or division was involved. And for D, I look for a common difference, meaning that addition or subtraction were involved. Those are the operations I look for first when I'm looking for patterns. But so I have this common difference of 3, meaning if I want to get to the next term, I would just add 3, right? Add 3. Well, that's how I want to define my recursive relationship. So what I'm going to say is my starting point is 35. And then if I want to get to the next term, right? If I want to go one term out, I take the previous term and I add 3 to it. And that's all there is to finding a recursive relationship, spotting the pattern, getting me a starting point, and then defining your current term in terms of a previous term. All right, thanks so much. Bye.